Imagine looking up at the sky and seeing the sun vanish, replaced by a dark circle surrounded by a glowing halo. This is a solar eclipse, a remarkable cosmic coincidence. A solar eclipse is an extraordinary dance of celestial bodies, where the moon, our closest neighbor, momentarily takes center stage, overshadowing even the mighty sun. But it's not just any dance, it's a ballet of cosmic proportions, set to the music of gravitational forces and orbital mechanics. So what makes this celestial ballet possible? It all boils down to a fascinating cosmic coincidence. The sun, our closest star, is about 400 times bigger than the moon. It's also about 400 times farther away from us than the moon. This unique alignment makes the sun and the moon appear almost the same size in our sky, enabling the moon to cover the sun perfectly during a total solar eclipse. But as with any great performance, timing is everything. The moon orbits the Earth and the Earth orbits the sun. However, these orbits aren't perfectly aligned and are slightly tilted in relation to each other. As a result, we don't get to see a solar eclipse every month. Instead, these celestial alignments happen roughly every 18 months, creating a sense of rarity and making each solar eclipse a unique spectacle to behold. The beauty of a solar eclipse is not just in its visual spectacle, but also in the deeper understanding it provides of our place in the universe. When the moon cloaks the sun, the day turns into night, the stars become visible, and the temperature drops. It's a brief moment of surrealism, an ephemeral reminder of the cosmic clockwork that governs our existence. In essence, a solar eclipse is a cosmic ballet, choreographed by the laws of physics and performed by celestial bodies. It's a breathtaking spectacle, a moment of wonder, and a reminder of our small but significant place in the universe. So, a solar eclipse is not just a spectacle, it's a testament to the precision of our universe. Now, you might wonder, if the moon orbits the Earth every month, why don't we have an eclipse every month? Well, it's all about alignment and a little thing called the moon's orbital tilt. Here's the thing. For an eclipse to happen, the sun, moon, and Earth need to be in near-perfect alignment. This alignment, however, doesn't happen every month. Why? Because the moon's orbit around the Earth isn't perfectly flat. It's tilted by about 5 degrees relative to Earth's orbit around the sun. So, most of the time, when the moon finds itself between the Earth and the sun, it's either a bit higher or lower than the line of direct sunlight. This means that the moon's shadow misses the Earth, and we don't get an eclipse. It's only when the moon crosses the Earth's orbital plane at the same time it's between us and the sun that we get to witness this celestial spectacle. But here's the twist. This alignment isn't a random occurrence. It's incredibly predictable thanks to something called the Saros cycle. The ancient Babylonians discovered this cycle over 2,000 years ago. They noticed that every 18 years, 11 days, and 8 hours, the sun, moon, and Earth return to approximately the same relative positions. This means that an eclipse will be followed by a nearly identical one just over 18 years later. So, if you missed an eclipse, don't worry. Just wait another Saros cycle and you'll get another shot. Of course, you'll have to be at the right place on Earth to see it, as the next eclipse in a Saros series occurs about 1/3 of the way around the world. It's fascinating to think that despite the vastness of space and the immense distances between celestial bodies, the movements of the sun, moon, and Earth can be predicted with such precision. So, while eclipses may seem random, they are actually some of the most predictable events in astronomy. Did you know that not all solar eclipses are the same? Yes, you heard that right. In fact, there are 4 distinct types of solar eclipses, and each one presents its own unique celestial spectacle. First, let's talk about total solar eclipses. These are the ones that probably spring to mind when you hear the term solar eclipse. They occur when the moon completely blocks the sun, casting a shadow that completely darkens the sky. For a few fleeting moments, you can see the sun's mysterious outer atmosphere, known as the corona. Total solar eclipses are truly a sight to behold, but to experience one, you need to be in a very specific location on Earth, directly under the moon's shadow. Next, we have partial solar eclipses. These happen when the moon only partially obscures the sun. From your perspective on Earth, it appears as if a chunk has been bitten out of the sun. Partial eclipses are more common and can be observed from a much larger area than total eclipses. Then, there are annular solar eclipses. These occur when the moon is at its furthest point from Earth in its orbit, making it appear smaller in the sky. As a result, it doesn't fully cover the sun, leaving a bright, fiery ring visible around the edges. This is known as the Ring of Fire, and it's just as mesmerizing as it sounds. To witness this, you need to be in the narrow path where the moon's shadow falls on Earth. Finally, we come to hybrid solar eclipses. These are the rarest of all, and they're a combination of total and annular eclipses. At some points on Earth, observers will see a total eclipse, while at others, they'll see an annular one. This duality makes hybrid eclipses truly unique. So whether it's a dramatic total eclipse or a subtle partial one, each solar eclipse offers a unique viewing experience. No matter which type you witness, one thing's for sure: solar eclipses are a testament to the beauty and complexity of our universe. Eager to witness a solar eclipse? Remember, safety first. There's something thrilling about watching the moon cloak the sun, turning day into an eerie twilight. But it's crucial to remember that looking directly at the sun, even when it's partially obscured, can cause serious damage to your eyes. The sun's intense light can burn the retinas, leading to a condition called solar retinopathy. This can result in temporary or even permanent vision loss. So how can we safely observe this celestial spectacle? There are several tried and tested methods. One of the most straightforward ways is to use certified eclipse glasses. These aren't your typical sunglasses. Eclipse glasses are specially made with a solar filter that protects your eyes from harmful solar radiation. But remember, not all eclipse glasses are created equal. Always ensure your glasses are compliant with the ISO 12312 international safety standard. Another safe way to observe a solar eclipse is to use a pinhole viewer. This simple device allows you to watch the eclipse indirectly. It works on a basic principle: light travels in straight lines. When the sun's light passes through a small hole in an object, it creates an image of the sun on the ground or another surface. To make a pinhole viewer, all you need is a piece of card, aluminium foil, tape, and a pin. Punch a small hole in the middle of the foil, tape it to the card, and voila, you have your pinhole viewer. Just remember to stand with your back to the sun and view the projected image on a light surface. Whether you're using eclipse glasses or a pinhole viewer, remember to only remove your protection during the brief moments of totality, if you're lucky enough to be in the path of totality, and put it back on as soon as the sun begins to reappear. With the right precautions, viewing a solar eclipse can be a safe and unforgettable experience. As we gaze upon these celestial spectacles, it's worth pondering their future. Imagine gazing up at the sky in the distant future, expecting to witness the breathtaking spectacle of a total solar eclipse, only to realize that such a phenomenon no longer occurs. This might sound like a plot twist in a science fiction novel, but it's an eventuality that astronomers predict will occur over the course of hundreds of millions of years. The moon, our faithful satellite, is gradually drifting away from us. Each year, it moves about 1.5 inches further into space. This slow but steady migration is due to the tidal interactions between the Earth and the moon. As the moon continues to recede, its apparent size in our sky will diminish. Now you might wonder, what does this have to do with solar eclipses? Well, the breathtaking totality we experience during a solar eclipse is possible because of an incredible cosmic coincidence. The sun is about 400 times larger than the moon, but it's also about 400 times farther away. This makes them appear nearly the same size in our sky, allowing the moon to perfectly block out the sun during a total solar eclipse. However, as the moon gradually drifts away, there will come a time when it will appear too small to completely cover the sun, even when perfectly aligned. The age of total solar eclipses will come to an end, replaced entirely by annular eclipses where a ring of sunlight always surrounds the moon. This change is not imminent. It's a transition that will occur over hundreds of millions of years, a blink of an eye in cosmic terms. Future generations will still marvel at solar eclipses, though the experience may be slightly different than what we know today. As we strive to understand more about our universe, each solar eclipse brings us one step closer to unraveling its mysteries. So, the next time you witness an eclipse, remember to cherish the moment. It's a cosmic dance that continues to evolve, just like our understanding of the universe itself.